All right, we'll get started any minute now. Let me just get this set up here. All right. All right, so good evening, everybody. We'll probably still have a few people trickle in as we go along with it. That's fine. So my name is Brian Greenblatt, and I am a meteorologist here at the National Weather Service in Binghamton, New York. Just a little bit about myself. I've been here about a little over 4 years now. April 2018 is when I started in the Weather Service. I'm originally from Long Island, so originally from downstate. While I was in college, I was a student volunteer at the Upton, New York National Weather Service office, also on Long Island. And again, I've been here about 4 years. I've done quite a few of these Skywarns at this point. Of course, about half of my time here has been during the pandemic, so all the Skywarns the last 2 years have been this format in a virtual setting. Eventually, hopefully sooner rather than later, we'll be able to do in-person ones again. But for the time being, we're still doing virtual. Today, I also have one of my colleagues here at the Weather Service office in Binghamton, Jake, and I'll let Jake introduce himself.
Yeah, hello everybody. My name is Jake Kalupski. I have been with the Weather Service for a year and a half, and previous to that, I was in the private sector doing aviation weather for the last 13 years. Just moved up to New York from Houston, and it's been quite exciting.
Yes, I had said that half of my time here has been during COVID. The entire time of Jake's Weather Service career so far has been the pandemic. So anyway, so Jake is mainly going to be observing this evening. He will be helping out with questions as well as we get towards the end. And also feel free, if you have any questions as we go, to type them into the chat box on your screen. And we will either Jake will respond in the chat, or we'll be able to address questions at the end. We'll also have a short break somewhere in the middle. I'll figure out where exactly when we get to that point. But a short, probably 5-minute or so break, just to get up and stretch. This way you're not sitting in front of a computer for 1 to 2 hours. This probably won't last the whole 2 hours. I know it says 6:30 to 8:30. Probably won't last that entire time, but we certainly can go that entire time if we have quite a few questions. I know we do have a pretty large audience compared to what we usually have for this one. So, all right, so I will get started. So here's an outline here of what we are going to talk about today. So we're going to start off by talking about what the National Weather Service is, for those who don't know, and what a weather spotter is. A little bit of a background about thunderstorms. Why are we concerned? A little bit about the ingredients of thunderstorms, what and how to report different products that we issue to get the word out, and then we'll have a time for questions at the end. This is the basic version of our Skywarn presentation. We have 2 versions of the severe weather format. So there's this one that is the basic, and then there's an advanced one that will go more into detail about the science and forecasting behind severe weather. So the basic one is pretty much like a prerequisite for those who want to take the advanced one. If you jump straight to the advanced one without taking the basic one, you'd probably be a little bit confused. We are offering, I believe, 2 basics. So this is the first of the 2, and then an advanced one. And the advanced one is on our website at the top of the page. There's a link at the top to register for that if you're interested. We also have a couple of other formats of the Skywarn program. We have the winter format, which we teach in the fall. That's more about winter reporting and how to measure snow. And then every once in a while, we do teach a flood Skywarn. A lot of times our hydrologist, Jim Brewster, is the one who leads that. So different formats of the Skywarn program that we do teach here at the Binghamton office. National Weather Service is pretty large. It's not just the Binghamton office. There are 122 what are called weather forecast offices across the entire country. So we are just one of them. So regardless of where you are in the country, there is a Weather Service office that forecasts for your area. There are also national centers. So there are river forecast centers. That's, if you can see the map, that's all these red squares. So we actually have two that forecast for our particular area. We have the Northeast River Forecast Center. They're based in Norton, Massachusetts, near Boston, and they cover the northern and northeastern part of our forecast area across central New York. And then there's the Mid-Atlantic River Forecast Center, which is based in State College, and that forecasts for the southern half or so of our forecast area. Again, there are also 6 regional headquarters. There are other regional centers as well. And Jake actually just came back from training in Kansas City. We have the Aviation Weather Center in Kansas City. So there's a lot of different national centers spread out through the entire country. But again, we are just one out of 122 what are called weather forecast offices throughout the country. A little bit about our office. We are located next to the Binghamton Regional Airport, which is about 10 minutes or so north of the city of Binghamton. At a 1,600-foot elevation, so we're on top of the hill, as we like to call it, which definitely makes a difference with weather, especially in the winter with snowfall amounts. We get quite a bit more snow at the airport, at the office, than Binghamton does itself. We forecast for Northeast Pennsylvania and Central New York. So actually, wrong button here. So here for Central New York, we have a good portion of the southern tier into the Catskills and a lot of the Finger Lakes regions, all the way up as far north as Oneida County in the Mohawk Valley. And then Northeast Pennsylvania, we have the 7 northeasternmost counties in Northeast Pennsylvania. This picture is a little bit small, but you can kind of see our neighboring offices around us. So we do have the Buffalo office to our west, the State College office to our southwest. We have the Mount Holly / Philadelphia office to our southeast. The Upton, New York office, also known as the New York City office, that's the office I was a student volunteer at. They border us with one county to our southeast. And then the Albany office is to our east and northeast. So National Weather Service mission, and this was actually very recently updated. So the mission is to provide weather, water, and climate data forecast warnings and impact-based decision support services for the protection of life and property and the enhancement of the national economy. The key here is the protection of life and property. This is our main goal. We definitely want to protect everybody, everybody that's around. We have a lot of key partners as well. The new addition to the Weather Service mission here is the impact-based decision support services. That's not something new in terms of what we've been doing. We've been gradually throughout the years, that's been more and more of an aspect of our job, basically briefing different event coordinators and core partners of incoming weather at specific events and things like that. And because it's such a big part of the Weather Service now, that has recently been added to the mission. Below that, I do have a few pictures here. So this right here is a picture of what our office looked like. This the December 2020 snowstorm, where we had 40 inches of snow almost entirely overnight. I was actually at the office for this one. I was extra on the midnight shift, and the day shift could not make it in. We couldn't get out, so I ended up working a midnight shift, day shift, double shift, along with 2 of my colleagues. Few other pictures here. So June 2018, this was only a couple months after I started working here. We did have a pretty significant tornado that hit a shopping center and a pretty heavily populated area in Wilkes-Barre in Northeast Pennsylvania. Bottom right here, just a picture of some flash flooding. That is our big severe weather in our forecast area. We do have quite a bit of flooding, as I'll go into in more detail later on in the presentation. And top right here, it's a picture I took of our radar. Probably a few years ago now, but that's a picture of our Doppler radar. So what is the Skywarn program? This is a national program run by the National Weather Service. So most offices, if not all offices, do have a Skywarn program, and some teach more courses than others. Some kind of limit it to just a few per year. We do teach quite a few. But regardless of where you are in the country, most offices do teach a Skywarn program. Not all have the winter version, depending on where you're located. And the goal is to provide the National Weather Service with ground truth reports of significant weather. So We have many tools at our disposal. We have the radar, we have satellite, but the biggest resource and the most useful resource is the ground truth. This helps us in real time. This also helps us directly after an event when we do verification as well. And it pretty much goes over exactly what I just mentioned here, but real-time reports do assist us in making our decisions in real time. It provides credibility to a warning. So if we hear about certain reports of damage, a lot of times you'll see the source in the warning. Instead of Doppler radar indicated, it may say train spotter indicated a report. I forgot exactly what it says, but something along the lines of that. And basically, it provides credibility to our warning. It also provides some life-saving information and can definitely help us both in real time and directly after the fact as well. So why are we so concerned about thunderstorms? Well, there are many hazards of thunderstorms, as many of you know. So we have lightning, high winds, hail, tornadoes, and yes, in our forecast area, especially flooding. So a little bit about lightning. So lightning is a bolt of electric discharge between the cloud and the ground, or within the cloud. Not all lightning reaches the ground. And whenever you hear thunder, that is the associated sound of lightning. One important fact here is that lightning can strike as far as 10 to 15 miles away from where it is actually raining. So what that tells you is that you do not have to be, it does not have to be raining to be at risk of being struck by lightning. So whenever, one of the many phrases that the Weather Service has, when thunder roars, go indoors, that is definitely to be taken seriously. If you hear thunder, you are close enough to be struck by lightning. Now here's a few infographics here. Here's that little buzz phrase I was just referring to, when thunder roars, goes indoors. A little bit about lightning safety. For a lot of you, this is probably common knowledge, but not everybody knows this. So definitely stay away from tall, isolated objects such as trees, poles, and things like that. You want to be off the water. So if you're boating, you want to kind of get away from the water. Open vehicles like lawnmowers, golf carts, things like that. A better location would be in a closed vehicle where you have the rubber tires to protect you a little bit. Unprotected buildings such as pavilions, rain shelters, bus stops, things like that. Metal, so if you're like fences, bleachers, let's say if you're at a baseball, like a little league field or something like that, you want to stay away from any bleachers and metal that's around there. And believe it or not, yes, you can be at risk of being struck by lightning even in your own home by using the computer, phone, washing dishes, using the shower. So that's certainly a risk of lightning as well. Just grab a sip of drink here. All right, so going into one of the hazards of severe thunderstorms being wind. The associated, the result of the severe thunderstorm is what's called a downburst, and that's when you have a descending column of air, a really strong downdraft, and that is where you get the highest winds. You can see that in this graphic here, where you have descending air here, and it kind of spreads out, and you have areas of high wind toward the ground. There are two types of downburst, a macroburst and a microburst. The only difference between the two is just how large the damage width is. So a macroburst is greater than 2.5 miles, a microburst is less than 2.5 miles. And one important thing here is that downburst damage can look similar or can actually be worse than tornado damage. A lot of times people will say, oh, I'm just under severe thunderstorm warning, no big deal. At least it's not a tornado warning. You definitely want to take a severe thunderstorm warning just as seriously as a tornado warning. Especially with these types of storms, a lot of times the damage is a lot more widespread than a tornado. A tornado may be a little bit more localized, especially in this part of the country. So let's see if this video works. Here's a time-lapse video of an example of a microburst. See that in slow motion. So there's your descending column of air and really high winds toward the surface. Here it is again. That's a pretty neat video. Definitely not very neat if you're in the middle of it, but looking at the video on YouTube is definitely it's a pretty neat phenomenon. Looking what a downburst looks like on Doppler radar. So basically on Doppler radar, we have many different products, and this would be described a little bit more in the advanced version of the course, the different products that we look at with Doppler radar. But two of the main products we issue when we are issuing warnings, reflectivity, which essentially indicates how heavy the precipitation is falling, and velocity, which is the speed and direction that objects are moving. In this case, you have the direction the wind is moving. So classic downburst signature is when you get the red and the green kind of, so red is away from the radar. So basically to the right side of this picture here, this is the side of the radar. So red is motion away from the radar and green is toward the radar. So you can see being toward the radar and being away from the radar right there. You have the signature, you basically have the wind spreading out on radar. It's a little bit different than a tornado signature, which I'll explain a little later. And again, downburst damage can sometimes look very, very similar to tornado damage. So in this particular example, you have a large swath of trees that are down. When we go out and survey, one of the things that we look at is which direction are the trees pointed. If they're kind of fanning out, that can be indication of a downburst signature. If they're kind of converging to a single point, that can be an indication of tornado damage. Of course, we also look at other things besides trees, if there's any damage to structures and things like that. But a lot of times, especially in our forecast area, a lot of these storms happen in relatively unpopulated areas, and most of the damage we're looking at is actually just trees. So in this particular image, you see these arrows. It's kind of, the trees are kind of pointing opposite directions from each other, kind of fanning out. And that is indicating of a downburst signature for damage. Here's a picture of a shelf cloud, kind of leading edge of a severe thunderstorm. This just happened to be the Melbourne, Florida office, but this can pretty much be anywhere. And here's a little loop here. What I'm going to do here is speed this up if I can. So this is a time lapse, and also I just sped it up 2 times, so it definitely doesn't usually move this fast. But just for the sake of time, I want to speed that up. It's a little bit concerning is that this person who's taking the video is pretty close and a lot of lightning nearby. So definitely don't want to be doing that, but it is a pretty good video. All right, so another hazard from severe thunderstorms is hail. A lot of people do confuse hail with sleet and vice versa. While the end result is very similar, being a kind of a ball of ice, they are formed very, very differently. Sleet is a form of winter precipitation, basically ice pellets, or basically snowflakes that melt on its way down and then refreeze as ice pellets. Hail is very different. Basically, you have circulation within the cloud, and you basically have these different droplets that are attaching to each other. Eventually, these droplets freeze and they become too heavy for it to be circulated within the cloud, and then it just falls down with the downdraft. So basically, that results in hail. The stronger the circulation within the cloud, the larger the hail is going to be. So a lot of times, if you see very small hail, there's really not as much of a circulation within the cloud. But when you do see really giant hail, that's a lot of times when you see quite a bit of movement in there. Here's a hail size comparison chart. Anything that is quarter-sized hail or larger, so 1 inch diameter or larger, is considered severe hail. So basically, severe hail is what you would expect to cause some damage. In this part of the country, we generally don't see giant hail, but it's certainly possible. This particular chart goes as large as CD, DVD sized. I really hope I never see that, because that would definitely be pretty damaging. But generally, a severe thunderstorm would be quarter-sized or larger. And most storms in our area are less than that. A lot of penny-sized hail or pea-sized hail, but we can certainly see hail that's larger. So here's an example of 3 inch diameter hail back in 2011, so about 11 years ago. And this is a video of, I don't know if any of you can hear it. So that was a video taken outside of our office many years ago. This particular case was nickel-sized hail, so technically sub-severe. Hail on radar is best seen using a vertical profile, but you can also see that in a 2-dimensional scale as well. And in this particular radar cross-section here, here you have the updraft, and then where you have the really high reflectivity or the really bright colors, where you get your pinks, your purples, and sometimes white on the scale. That is where you have the hail. So a couple of fundamental definitions: a tornado versus a funnel cloud. So a tornado is a violently rotating column of air from a thunderstorm and in contact with the ground. The two keys here: rotating and in contact. So you may have a rotating cloud, but if it's not contact with the ground, it's a funnel cloud. So a funnel cloud is a rotating cloud extending from a thunderstorm base. The funnel cloud is attached to the cloud base and does not reach the ground. Later on in this presentation, I'm not sure if it's not the next slide, but later on there is an example of what's called a Scud Cloud. And basically, a Scud Cloud may look like a funnel cloud. It's not in contact with the ground, may look pretty ominous, but it is not rotating, and it's actually generally not hazardous. So that's one thing to keep an eye on. All right, so Doppler radar winds. Again, earlier I showed an example of a downburst signature on Doppler radar. This is an example of basically a tornado signature on Doppler radar. So again, red is moving away from the radar, green is moving toward the radar. And when you have them the red and the green really close together, that indicates you have strong wind going one direction and strong wind going the other direction. And in this particular case, we have 39 miles per hour going away from the radar, 64 miles per hour going toward the radar. So you basically have, pretty intense rotation within that location. Generally, for it to be a classic tornado signature, this would have to be what's called gate to gate, or very close together. In this case, it is very close together. Sometimes we'll see more broad rotation. Maybe this bright red will be over here, and the bright green will be up here, and it's indicating a broad rotation, but it's not quite tornadic yet. So that's why a lot of times where there may be rotation on the radar, it may be a severe thunderstorm warning. We might even have the tornado possible tag in the severe thunderstorm warning, but we're probably holding off on a tornado warning if it's more of a broad rotation. So here's another pretty impressive loop here. So I'm going to kind of skip through this here, but here we have a funnel cloud. Here we have a funnel cloud, and it's not quite reaching the ground yet. And you can see it's starting to lower. Not quite reaching the ground yet, but it's almost there. And it looks like almost right in around now or so is when you have it touching the ground. So now all of a sudden that funnel cloud is now a tornado. And you can see how quickly it develops. It went from, it's a pretty narrow tornado and it's still trying to reach the ground, to now it's a pretty impressive looking tornado, becoming larger and larger. Again, going from the beginning here, it's the funnel cloud to the end where you have a pretty significant tornado on the ground. Now, as I mentioned earlier, there is a difference in terms of tree damage from tornadoes versus severe thunderstorm or downbursts. So with the downburst, remember we had the trees kind of fanning out opposite from each other. And when you have tornado damage, you basically have them converging to a single point. So here you have trees that are fanned down toward the right, and here you have it toward the left. And you can kind of see that they kind of converge to a single point in the middle. It's also impressive about this image here. If you can notice, there's a little bit of kind of a scar in the field here. That is the track of the tornado. The tornado can actually kind of draw a path on an open field and kind of turn up the crops a bit. So that's just an example of tornado damage. This particular example was from 20 years ago now, but it's a pretty good example. Here's an example of just a few trees down in our area from a few years ago, back in 2019. This was from an EF0 tornado. It's the weakest on the scale in Scranton. And if you look closely, you can see the trees are pointed in opposite directions, kind of pointing towards each other. And you can kind of indicate that as well. I just hinted at the enhanced Fujita scale. Here it is. So the enhanced Fujita scale is how tornadoes are rated from EF0 to EF5. Back in the day, this was called the Fujita scale, so they were rated F0 to F5. I think it was 2007 or so, right around then, where the scale was revised a little bit based on the damage indicators, and it's called the enhanced Fujita scale. So you can see actually even in that picture from before, this caption here from an F3 tornado, this is before the scale was changed, and now it's the EF scale. So it goes from a 0 to a 5. And the other hazard from severe thunderstorms, remember going back to that first slide where we had a bunch of different hazards. So flooding is definitely our big concern in our area, and may wonder, well, why is it such a big concern? Well, you can see on this topography map, there we have quite a bit of change in elevation in our forecast area. We have the Catskills in the eastern part of our area. We have the Poconos. We have the higher elevations of central New York, the Tug Hill Plateau on the northern edge of our forecast area. We have quite a few mountains in Steuben County, our far western part of the area. And therefore, you have quite a bit of slope terrain and moderate to poor drainage. Our two biggest flash flood counties, it's not a coincidence, that's where you have your highest elevations. So that's in Delaware County and also Steuben County. Those are our two biggest flash flood counties, but we do get flash flooding in various parts of our area. So differences between warnings and advisories for flooding. So you have a flood warning. Generally, it happens over a longer period of time, greater than 6 hours or so. And this is when you expect flooding on rivers, lakes, other large drainage areas. You also have what's not listed here is a flood advisory. That's when we're expecting. It may be a quick hitting, but it's a little bit less severe than what would be a flash flood warning. Flash flood warning is when you have rapid flooding that's expected on small streams, creeks, developed areas, and it takes less than 6 hours to occur. Sometimes can be as soon as minutes. So these are especially hazardous. New as of a few years ago, I believe it was 2019 when we started this. There are now 3 tiers of flash flood warnings. So you have a base flash flood warning, a considerable, and a catastrophic tag. Catastrophic is your flash flood emergency. The base one, while in the past all flash flood warnings would go off on your cell phone through the wireless emergency alert system. Now base flash flood warnings do not. It's just the considerable and the catastrophic ones. So as a warning forecaster, we have to decide the potential impacts of the flooding depending on the severity of it. And then you also have river flood warnings. So we do have quite a few rivers in our area, especially the Susquehanna Basin and the Delaware. So river flood warning is when you have flooding likely on the main stem rivers. All right, you can see from this is just a small list here of different floods, famous floods or infamous, depending on perspective, floods that have happened in our area. I do remember my first summer here, 2018. We had pretty significant flooding in Northeast Pennsylvania, and even a few areas, the Finger Lakes had some major flash floods. 2 of the biggest flash floods in our area happened. One was in 2011 from the remnants of Tropical Storm Lee. And then in 2006 was another one. And then actually we're approaching the 50th anniversary of Hurricane Agnes, which is here, 1972. That was also a major devastating flood. So we do have a pretty extensive flood history in our area. Here's just a little bit about kind of comparing it to a recurrence interval, basically. So your 500-year floods are your most rare type of floods. That's basically a flood that on average would happen one in every 500 years or so. And then Agnes was an example of a 300-year flood, once in a 300-year flood, and so forth. So what is a severe thunderstorm? So a severe thunderstorm, it's a storm that produces wind gusts of 58 miles per hour or more. Why 58 miles per hour? That statistically is where you have more significant structural damage. It may sound like an odd number, but that's actually equivalent to 50 knots. So it's an even number when you convert it to knots. Hail 1-inch diameter or larger. So again, as I mentioned earlier, that's quarter-sized or larger. And then of course, a tornado is also severe. Just keep in mind all thunderstorms, whether if they're severe or not, do have lightning and are dangerous. So climatology of severe thunderstorms with tornadoes. So this is a graphic here that shows known tornadoes that occurred in our area between 1950 and 2018. You can kind of see here we have a few what are sort of tornado alleys, some areas that we had quite a few more tornadoes than others. Parts of Northeast Pennsylvania do get a few more tornadoes than other parts of the area. And then even actually, so it's kind of the extreme ends of our area, the southern part of our area, Northeast Pennsylvania, and then the northern part, more towards Oneida County. We always joke around that that the reason why that happens is it's as far as you can possibly go in our area in terms of driving distance when we survey the damage. Because usually if we're surveying damage in Oneida County or like Steuben County or Luzerne County, for example, it's generally a couple hours of a drive or more. The other one was a picture of all tornadoes. This is just EF2 or stronger tornadoes. You can see it's pretty rare that we have really significant tornadoes in our forecast area. This goes through 2018, so this does include the Wilkes-Barre tornado that happened in 2018, which I believe is the one that's over here. I don't know if you can see my pointer. Look at wind. So most of our damage is not necessarily from tornadoes. It's just severe wind damage. That's known thunderstorm wind gusts of 58 miles per hour or more, and it's pretty much area wide. One thing you'll notice is there are more reports of 58 mile per hour winds the higher population areas across the Hudson Valley, more towards Long Island, New York City, and then of course New Jersey. And it seems like it's a little bit less in our area. That's solely based on population. More people, that means more people are going to have wind damage or wind reports. So that's just a result of the population. And then same thing with hail. We do have quite a bit of hail reports in our forecast area. This is known instances of large hail, so 1 inch diameter size. I'm sorry, 1 inch 1 inch diameter size or larger. And then prior to 2010, the criteria was actually penny sized, so that includes both of those on this map. So the severe weather season. Oops. So severe weather can happen any time of the year. We certainly have had severe weather in January. We've had severe weather in December, November. But the bulk of our severe weather does occur from anywhere from mid-May or so until the beginning of September. And that's generally where you have the warmest time of the year, the most instability, and so forth. But again, it can happen any time of the year. So just because, let's say it's February, for example, and you're expecting it to be snowy, we could have an abnormally warm pattern, and it may have some severe weather as well. Likewise, time of the day, generally, most severe weather occurs between the hours of 2 p.m. and 7 p.m. However, it can happen any time of the day. So you can have early morning severe weather, overnight severe weather. I do remember back in 2019, I was actually in Norman, Oklahoma for radar training, and we had a severe weather event April of 2019. That was an overnight event here in our forecast area. So go figure, I went to Norman, Oklahoma for radar training, and the severe weather was happening here. All right, so some of the ingredients for thunderstorms. So we have 4 main ingredients: instability, moisture, lifting mechanism, and wind shear. So I mentioned about the bulk of the severe weather occurring during the afternoon. Why does that happen? That's when you have the largest difference between the surface and higher up in the atmosphere. That's known as instability. Generally, you have daytime heating, so to kind of produce this instability. At night, you may have some elevated instability left over from the daytime, but the greatest instability is generally during the afternoon. One thing that you'll notice a lot of times is if a lot of the severe weather events we get, like the lower end ones, we may have a batch of rain in the morning, and then it's questionable if it's going to clear out enough. And that creates a pretty big forecast challenge, because if it clears out, then it's going to create more warmer air at the surface and create more instability. Meanwhile, if it doesn't clear out, it's going to be cooler and create less instability. So instability is directly proportional to updraft strength, which is directly proportional to the strength of the storm. So the stronger the instability, the stronger the updraft of the storm, the stronger the rising air of the storm. There are 3 main types of thunderstorms. You have ordinary thunderstorms, which have generally 30 to 50 mile per hour updrafts. That's your rising air. Severe thunderstorms, you have 50 to 70 mile per hour updrafts, and supercells, which are your strongest type of storms generally, would have greater than 100 mile per hour updrafts. So I mentioned the updraft, the rising air here. This is an example of an overshooting top or an anvil appearance. And you can see here, this is probably the view you would get from an airplane. And you can see this little bump here on this cloud. That's where you have the overshooting top of the storm there. Moisture. And you may think, well, we're not along the coast. We don't have any moisture sources. Well, we do have plenty of moisture sources. We do have the Great Lakes. Of course, that's a big factor for winter with lake effect snow. But we have the Great Lakes relatively nearby. The Atlantic Ocean is close enough that it does bring in some additional moisture. And then there's some air masses that bring southerly winds and warm, moist air from as far as from the Gulf of Mexico. Gulf of Mexico obviously being very warm and humid down there, a lot of moisture. And so we do have plenty of sources of moisture. And again, moisture increases instability, increases the updraft strength. And if there's enough of it, you can also have flooding as well. Just a slide here about moisture increase in the updraft strength. Again, the moisture condenses to form the clouds, and you have heat that's released, and that can cause more instability as well. You also need a lifting mechanism. So a lot of times in the summer, you'll have kind of these pop-up weak thunderstorms, and which are mainly instability induced. It's the pretty warm, humid air, but they may not be very intense, and they may be very slow moving. And one of the reasons for that is the lack of a lifting mechanism. You're not near a frontal boundary, you're not near mountains or anything like that. So basically, lifting mechanism can be a front. So here you have an example of a cold front. It could be a warm front. Basically, it's a trigger for rising air for the thunderstorm. Remember, you want rising air to get the more significant thunderstorms. Here's an example of a warm front. It's kind of the same thing, where you have the warmer air displacing the cold air instead of the cold air displacing the warm air. In the cold air, the warm air rises, and you get the lifting mechanism. Then, of course, mountains as well. We do have plenty of mountains in our area, as I mentioned earlier. And then wind shear. So wind shear is basically a change in wind direction and wind speed with height. Jake would know plenty about this, having an extensive career in aviation. So this is especially problematic for aviation folks. When we do the aviation forecast, we do factor that into the forecasts. But that also is another ingredient for thunderstorms. So if you have high instability and high wind shear, that is when you are pretty significant danger as well. So a lot of times early in the season, so this is considered early in the season in April, we have high wind shear but low instability. And a lot of times later in the season, later in the summer, it's actually the reverse, where we have low wind shear and high instability. And in your major events is when you have a decent balance of the two. All right, so we have three main types of storms here. So we have a single cell, multi-cell, cluster or line, and a supercell. So again, this is directly proportional to the updraft strength, and the shear. So the single cell is where you have the weakest. Oops, let me do that. The weakest updraft strength. Here you have the updraft, and then you have the downdraft of the thunderstorm as well, and that's creating the descending winds, and you have your downburst. So generally it's straight up, straight down. Multi-cell cluster or line, again, that's going up the shear scale. You have a little bit more shear involved. A lot of times you can get some back building and create some flash flooding issues. So basically you have the updraft, and you have more cells developing kind of behind it, and you have what's called a multi-cell line of thunderstorms. And then you generally, the most intense version of this is what's called a squall line, or a QLCS, a quasi-linear convective system. Generally, what we'd like to say is that the worst is first. The leading edge of this squall line is where you have the most intense everything really, most intense wind, most intense rain. This is where your greatest risk for tornadoes is. Your greatest risk for tornadoes. They're a little bit harder to detect on radar, and this is described a little bit more in the advanced version of the course. But they're a little bit more difficult to detect with the squall lines, only because it's kind of embedded within the line. And sometimes you get a squall line and creating kind of like a bowing feature here. So what's called like a bow echo. And this is when you have the really intense squall lines and quite a bit of straight line damage. And this is probably a little bit more technical than it really needs to be, but essentially you have the basically the air kind of injecting into the line and kind of creating this little bow feature here. And you have a bookend vortex and a rear inflow notch. This is where your highest winds are going to be, the leading edge of that bow. And you can see that here in the velocity image here. You have 80 to 90 knot winds on that area. Long long-lasting bow echo or long-lasting squall lines are called derechos. So the one significant one that happened in our forecast area was back in 1998, also known as the Labor Day derecho. Unfortunately, there actually were a couple of fatalities at the New York State Fairgrounds. That's around the time the New York State Fair is held. This is what I was mentioning earlier when I was talking about our mission statement, the decision support services. A lot of times we will have a meteorologist deployed to one of these events now and kind of briefing all the event coordinators, the emergency managers, and everybody like that for incoming weather. This is something that was not really the case back in 1998. Then you have supercells. So supercells, again, have your strongest updrafts. This is where you have an increased risk for tornadoes. Generally, supercells are most commonly found in the Midwest, the central part of the country. However, we do get supercells in our area every once in a while. The 2018 Wilkes-Barre tornado being a perfect example of one. And then you have the question of how does wind shear contribute to tornado supercell formation? So I mentioned earlier, you have a really, really strong updraft and you have rotating air. Eventually you have so you basically have the rotation tilting more of a horizontal direction due to shear. More of a vertical, sorry, from a horizontal direction to a vertical direction because of shear, and that's when you'll get more tornadoes. A lot of times it doesn't reach the ground. Again, that is a funnel cloud, not necessarily a tornado. When it reaches the ground, it would be a tornado. Visual sign of a supercell. Again, you have the overshooting top as a sign of a strong updraft. And remember, the supercells have the strongest updrafts. This is a type of cloud that you a lot of times see with incoming supercell thunderstorm. It looks pretty neat, but it's actually pretty dangerous. It's a sign of a lot of instability and a possible severe thunderstorm that's approaching the area. Supercell, a lot of times you'll see this on TV, the classic hook echo or the hook signature, and this is where you get the classic looking signatures here of tornadoes. This particular example is actually eastern Broome County, and you have quite a bit of rotation as well. Here's another example of a tornado touchdown. Remember earlier I was telling you about the gate-to-gate velocity signature, and here you have pretty strong motion towards the radar in green and pretty strong motion away from the radar in red, and you have that rotation there as well. I've referred to this tornado quite a few times at this point. This is a good drone footage. I'm not going to show the whole thing because it's about 5 minutes long, but this was drone footage that was taken from the aftermath of that tornado. Fortunately, this tornado did occur pretty late in the evening. It occurred around 10 o'clock. So most of the stores in these shopping centers were closed. There were no fatalities, and any injuries were minor. Kind of see here, this is actually a U-Haul, I believe a U-Haul facility. You had trucks that were thrown around, kind of like toys. So I did not go on this particular survey. One of my colleagues who started around the same time I did, she did go on this survey, and this was her first tornado survey. So this was a pretty significant tornado, especially for the Northeast. There's the YouTube link. All these slides I'm going to be sending out to everybody, probably tomorrow, possibly late this evening, but most likely tomorrow. And you'll get all the links to this, all this, and everything like that. A wall cloud is when you have a rotating, lowering section of a thunderstorm. It marks the storm's strongest updraft area, and this is where your severe weather is likely going to occur. Again, rotation is the key. If you have a rotating wall cloud, you do have a likelihood of possibly seeing a tornado, or at the very least, a really strong downburst. When you see a brightening of a wall cloud, that can be a precursor to tornado development. I mentioned this earlier. Scud clouds may look pretty ominous, but they may not necessarily be that, or they're not that bad. They really don't. They don't show much of an issue. They can be low, but they're generally not severe. And the key here is that they're not rotating. So here you can see an example here. See that, you'd be like, oh my gosh, it's a lowering tornado. It's a funnel cloud, and but look, it's not rotating. So it looks pretty ominous, but it's actually not too much of an issue. A little bit about tornado safety. So whenever you do have a tornado warning issued for your area, you want to get into the lowest level of your home, away from windows. If a basement is not possible, at least go to an interior room, again, away from windows. It can be a closet, a bathroom. You do not want to put yourself in harm's way, and I'm going to emphasize this a lot, especially towards the second half of the presentation when I talk about reporting. You do not want to put yourself in harm's way when you are giving us a report. When it's safe to do so, certainly feel free to give us a report, but if you're in the direct path of a tornado, don't go outside and start videoing a tornado. Get into the lowest level of your home, away from windows. I think now is a good time for a short break. Let's see, it's 7:22. Let's take a 5-minute break, and at 7:27, we will resume. Jake, have there been any questions so far?
If there have, I can't see them. I think we're having the problem that we thought might happen.
Okay, let me see if
So
I
I
see them.
only have options to send questions to you. So
Okay. All right, we do have a few questions, so we'll answer these questions at the end. Somebody had issues hearing me.
I didn't have problems, so that might have been that's probably on their end. The only thing I can think of doing is joining the webinar from the storm report.
Well, that's what I'm in right now.
Yeah. Otherwise, I can't see anything or do anything.
Okay, that's fine. We'll just, to avoid it crashing, I think it's better if we just leave it as is. It's at least working as is in terms of audio and everything. So at the end, we'll address any questions, and maybe Jake can help out answering the questions as well toward the end.
Yeah. We'll get this thing figured out eventually.
There's not too many questions so far. It's 1, 2, 3, 3 questions, 2 comments. So somebody did say the anniversary of the 2011 super outbreak is a great timing for a Skywarn class. I did not realize it was the anniversary of the 2011 super outbreak.
I mean, either.
As far as the questions, I'll go through those at the end. I'll be right back. All right, so we will resume the rest of our Skywarn, and then again at the end, we'll have an opportunity for questions. All right, so the second half of our presentation is going to be more on what to report to us, how to report to us, and then also different ways we get the word out to everybody. So the first half was a little bit more of the science-based about the thunderstorm development and things like that. The advanced version will go into a little bit more detail about that, especially different. A lot of times we show the Storm Prediction Center meso-analysis page for those who are familiar with that. So what to report? This is a graphic that I stole from one of our neighboring offices, the State College office, which I thought was a pretty good resource. So what you want to report to us is your time, location, condition, source, also known as, so time, when did it occur? Where are you? If you're not sure, you can give us a nearby intersection. What are you reporting? And then who are you? So by the end of this, you will all be trained spotters. So that is, when you say who, answer the question, who are you? You're a trained spotter. So for example here, hi, this is John. I am one of your spotters, and I'm calling to report hail. So again, who are you? Trained spotter. What are you reporting? Hail. I'm located in Lancaster City. So where? Lancaster City. And we've got at least quarter-sized hail falling right now. So what are you reporting? It's at least quarter-sized hail. When it is occurring? It's right now. Sometimes when you call us to report, it happened an hour ago, for example, so you definitely want to mention that as well. Different things you can report to us. Wind damage, so any uprooted trees, large branches down, wires, damaged infrastructure. Hail damage, hail of any size. You can please measure with a ruler with a common object to get an accurate sizing. Funnel clouds and tornadoes, and then also flooding. Again, the key thing I want to emphasize here is only if it is safe to do so. Please do not put yourself in harm's way to give us a report. We want you to be safe. If you are able to safely get pictures, definitely that helps as well. So when you're reporting wind damage, let's say if there are trees down. Well, how many trees are down? Is it one tree or is it a whole large swath of trees? How big are the branches? Are they small twigs or are these large branches from the tree? What was the health of the tree beforehand? A lot of times the tree may not have been healthy beforehand. A pretty good sign of that in the summer, if there's either very few leaves in the trees, or if the trees are changing colors very early, in like early August, it's probably a sign it's not very healthy. You can probably tell if it's not a very healthy tree. If it was really strong wind, do you have any damage to the buildings? For example, windows are blown out, roofs blown off, or is it just a tree damage? And can you potentially estimate the wind speed? You may wonder how to estimate the wind speed. Well, twigs or small branches broken generally take about a 40 to 50 mile per hour wind gust to knock down. Larger branches down, smaller trees uprooted anywhere between 58 and 70 miles per hour. So that's when you're getting into the severe category. So keep in mind here that the top, twigs, small branches broken, that is actually sub-severe criteria. Larger trees uprooted, 70 to 80 mile per hour winds, and larger trees snapped, or trees snapped and large trees uprooted, and you start getting structural problems. That's 80 mile per hour winds generally, or larger, or higher. One thing that is noteworthy here, it does take more wind to snap a tree than it does to uproot a tree. Even though uprooting may sometimes look more impressive, it's actually the snapping that is more impressive in terms of wind speed. Again, I'll be sending all these slides to everybody probably tomorrow, but how do you make your report? You give us a call at this number here, 1-800-759-2992. This is for reports only. Please do not pass this along to your friends for somebody to get a forecast. please don't ask for a forecast on this line for your own sake. This is just for reports. Or you can email us at bgm.stormreport@noaa.gov. And there are a couple of other methods I'll show in the next few slides to report to us as well. Again, when you are reporting, please mention who you are. So you're a trained spotter for whatever county, what you saw, where you saw it, and when you saw it. If you have your lat lon, that's certainly helpful, but you don't really need to report that if you don't know it. But we can, in our program, when we enter in reports, we can directly enter in a latitude and longitude. So if you do have that, if you want to report it, go ahead. Another way to submit a report is online. There is this pretty neat, and I'll actually show you all this. I'm not going to actually enter a report. There is going to be a point where I'm going to stop. Let's say, oops, let's do rainfall. Next. And then enter the time that you observe the weather, the date, what exactly you're reporting here. So in this case, it's rainfall, so the measurement. If you have a gauge, if you're estimating the rainfall. You can also provide any additional comments, such as how long it's rained, or if you have some flooding. And then you would press next and kind of follow the instructions on how to send it. It would ask for your location next. And the same thing applies for really anything. So even tornado, same thing. So close that. There is actually called a new, not really new anymore, but a new-ish app called MPing. This is a way to report both damage, so you can report like trees down, things like that on there. Or you can, and this is what it's really helpful for, is during the winter, reporting different precipitation types. So in the winter, you may have, I don't know, like a mix of rain and snow. You can enter that. If you have sleet, you can enter that. But you can also report hail sizes on this. That's also really helpful as well. So you can do a bunch of different things with this app. You can either download the app, or it's actually available on some radar apps as well. You can report to us on social media. So we have Facebook, Twitter, and we also have an experimental Instagram page as well. The one caveat, though, is that social media is not our primary source of information. So sometimes it goes down, and that's out of our control. There was a few years ago where we were actually locked out of our own Facebook account. That was out of our control. That was a Facebook issue. And we couldn't post for about 2 or 3 weeks. So we're subject to the same technical issues that you may be on your own personal pages. So definitely don't rely on this, but it's certainly another way to get information and also another way to report to us as well. Again, so you can call this number, the toll-free number, send us an email, you can enter online, you can enter an MPing, enter in social media, and if you're an amateur radio operator, you can also report on there as well. Okay, so different ways of getting the word out. So this is another graphic, and you'll see a few other graphics I took from State College because I kind of like the way they look. It's pretty simplified. So here we have the outlook to warning phase. So the National Weather Service goes with a 3-tiered approach, starting with outlooks, which is furthest away from the event time-wise. And then as you get closer to the event and also confidence increases, you go to a watch and then a warning. So it's a little bit different, winter weather versus severe weather. In the winter, we may have our hazardous weather outlook out for a potential snowstorm 5 days from now. And then maybe a couple days ahead of the event, issue a winter storm watch. And then maybe 12 hours ahead of the event, issue a winter storm warning. With severe weather, it's a little different in that you still have the outlook phase. It's kind of the same thing. The watch phase is a little bit closer in time. It's generally within about 6 hours or so. That's collaborated between us and the Storm Prediction Center in Norman, Oklahoma. We'll have internal collaboration calls with that. And then a warning is what we call short fused with severe weather. Warning means it's imminent, it's about to happen, or it is happening right now. So again, difference winter weather and severe weather. Winter weather, it's expected next 12 hours or so, but in severe weather, it's happening right now or it's about to happen. Mentioned about the hazardous weather outlook. Again, that's the furthest away from the event. This is the most general outlook. This is available on our website. In fact, I believe we have fire weather concerns at the moment. So, okay, so we actually do have a good example on our website at the moment. So here, if you go to hazardous weather outlook, some of our zones, we don't have anything out. But we do have a fire weather watch for our Northeast Pennsylvania counties for Thursday and Friday. I'm not sure. That's weird. Looking through this, I don't actually see anything for, just real quick. Yeah, that's a glitch. Yeah, we don't actually have anything in the hazardous weather outlook for New York. It's just Pennsylvania where we have the fire weather watch. I'll actually pass that along after this. Anyway, so let's go back to, and while I'm on our website, I did mention this earlier about our Skywarn schedule. At the top here, we have a Skywarn training schedule. So if you click on that, we do have another basic one on May 9th, the advanced one on May 11th, and tentatively, we have an in-person one on May 23rd. That is very, very tentative. If that was today, we would not be allowed to do that. So that's all dependent on how things go pandemic-wise. But we're hoping to start rolling out some in-person ones as we are allowed to. Back to the presentation here. I mentioned about the Storm Prediction Center. The Storm Prediction Center has their own outlook system. They have different categories for severe thunderstorm risks, ranging from just general thunder to a high risk. It is a little bit confusing at times with the wording. It goes on a scale of 1 to 5, marginal being the least significant, 5 being the most significant. But then you have enhanced ahead of moderate. It's a little bit confusing. But anyway, they do have their own severe thunderstorm risk categories, and that's based on their expectation of coverage of the event, also the setup in terms of meteorological expectations. The one caveat here is don't let your guard down when you're only in general thunder or only in marginal. There have been occasions where severe weather has occurred when we're in a general thunder risk, and there are occasions where we've had a significant severe thunderstorm event and only a marginal risk. So the point here is definitely use this as a tool in terms of looking as a general idea of what may happen, but don't say, oh, I'm only in a marginal risk. It's no big deal. It's always a good idea to be prepared. So I mentioned about the difference between a watch and a warning. Again, the warning for severe weather basically means take cover now. Watch is the conditions are favorable for severe weather, but it's not imminent. Oops. So many different ways to receive our warnings. NOAA Weather Radio is the most, probably the oldest way, but it's probably one of the more reliable ways to get our warnings directly from on the weather radio broadcast. They'll interrupt the normal broadcast anytime there is a warning issued. For our core partners, there's something called INWS for emergency managers. The WEA, that's your wireless emergency alert system. So that is when you get anything on your cell phone. It is highly recommended that you do not shut these off. I know sometimes those alerts get annoying, but they can save your life. So try not to shut them off. You have the EAS systems, of course, it will go off on radio stations and on TV stations as well. One thing that I want to point out is anything that gets relayed to your TV if there's a weird glitch in terms of you getting a warning that's not in your area, or it doesn't stop scrolling or something, that is actually out of our control. That is a complaint we get quite a few times. It's out of our control. That is more for the cable provider or your TV provider on their end. We're the ones that issue the warnings, but in terms of disseminating it to the TV, that is not what we do. All right. So go to our website, weather.gov. This is the national homepage. And then the important thing here is wherever you are in the country, there is a Weather Service office. So if you are in Texas, for example, let's say you're where Jake was living before this in Houston, you can click on that area and you can get the forecast for from the Houston office. For our area, you can click in Central New York or Northeast Pennsylvania, and you'll get to our website, weather.gov/BGM. And this is an example of a pretty quiet day, but a busier day may look like that. So a busier day may have a severe thunderstorm watch, flash flood watch, and so forth. Again, the wireless emergency alert system is a really good way to get our warnings. This is on your phone. You get the cell phone alerts. I mentioned earlier about the flash flood warnings. We now have a 3-tiered system. There is also now a 3-tiered system for severe thunderstorm warnings. I'll mention in a few slides from now. So not all warnings will go to your phone. While we do not have an app, we do have a mobile-friendly website called mobile.weather.gov. And this is our website in just a more mobile-friendly version where you can save it to your home screen on your phone, and it behaves just like an app. Okay, and this is what I was just referring to. This is brand new as of last summer. This was postponed a few times last year. This was supposed to, I think, originally come out last April, then was moved to June, I think, and I believe it eventually rolled out in mid-July. Several years ago, there was a change to what are called the impact-based warnings, and basically this made the warnings to be a little bit more easy to read, especially machine-readable tags at the bottom, and it included like a hazard, source, impact bullets in the body of the warning. What is new now are the different threat categories for severe thunderstorm warnings. So we're going to this next slide here. A base severe thunderstorm warning. So 58 miles per hour. It's anywhere between 58 miles per hour and 70, or 69 technically. Or 1-inch diameter hail will not go off on your cell phone. A considerable tag, which is 70 mile per hour winds, or golf ball sized hail, or will also not go off on your cell phone. However, a destructive tag, so 80 mile per hour winds or baseball sized hail or larger, will go off on your cell phone. In the past, severe thunderstorm warnings, unless if you had it through a third-party app, did not go off on your cell phone. It was just tornado warnings. Now the most significant severe thunderstorm warnings will go off on your phone directly through the WIA system. And the same thing, again, a few years ago, we did something similar of flash flood warnings. The only difference is, so the base one does not, the considerable and catastrophic categories for flash flood warning do. So it's the top 2 categories for flash flood warning. It's only the top category for severe thunderstorm warnings. So here's an example. At the bottom of every warning, there is machine readable tags at the bottom. So example from the base here, I have circled. So hail of 1 inch and 60 mile per hour winds. Considerable. So now it says that thunderstorm damage threat considerable. And what triggered this particular warning was the fact it was 70 mile per hour winds, even though it's still 1 inch diameter hail. It's the 70 mile per hour winds in this particular example that triggered it. Destructive. In this particular example, it's the hail size, and you still have 70 mile per hour winds in this example. Or in this example here at the bottom right, you have 90 mile per hour winds. Again, that would go off on your cell phone. So we're heading towards the last few slides here, and then we'll open it up for questions. in summary, and I mentioned this at the beginning, but I just want to emphasize this fact. Spotters help us in real time. It helps us determine what is happening on the ground. We do have our own resources. We have the radar, we have satellite, and we also get reports from the general public as well that may not be trained spotters. Trained spotters provide credibility to the warning. And it also allows us to give advance warning to those in the path of the storm. So let's say, for example, we have a warning out for, let's say we don't have a warning out for Tioga County, New York. And all of a sudden we get a report from a trained spotter of widespread trees down, and it's about to enter Broome County and right into the Binghamton area. Well, that may be enough for us to upgrade it to a severe thunderstorm warning. Of course, we're also still looking at what's going on radar and satellite, but that's just another potential trigger for us to issue a warning. Likewise, if we have a warning out and we're just not getting any reports, and it's a pretty heavily populated area, and we should be getting reports, well, then we'll be like, maybe it's not actually as severe as it looks on radar. So that's something that we always keep in mind. This just kind of emphasizes the same point. We want to issue warnings before the severe weather occurs. We do not want to issue warnings for non-severe weather events. Real quick here, you do not need to call us for very general, vague reports. For example, it is really windy outside, or lightning just struck across the street. It's really loud. You don't have to call us for that. However, feel free to report any wind speeds or hail. It does not necessarily have to be severe criteria. If you have nickel-sized hail, for example, feel free to report that. If you have some tree branches down and thinking it's probably about 45-mile-per-hour winds, you can call us about that as well. So anything helps, but you don't have to send us give us a call that it's really loud outside with the thunder. And real quick, I just added the slide. I was talking to our observing program leader here at the office just a couple hours ago, and she wanted me to pass along about the Coco program. So the Coco program is, and I'll show you on the website here, but it's a nationwide program where you can put in your rainfall and snowfall measurements, and it's another way of us getting observations. You do not need to be necessarily a trained spotter to do this. You do not need to be really experienced to do this. You can be young, old, in between. Anybody who wants to report rainfall measurements or snowfall measurements can do so. The caveat is, if you do measure rainfall, you do need to purchase a 4-inch rain gauge, and there's a link on the website to purchase one. And I'll actually show you the website real quick. Just give me 1 second here. All right, so cocoros.org. And then on the left menu, you go to join Cocoros, United States. And then just fill in all your information. It's pretty self-explanatory. Again, you do have to, if you're going to be doing this, you do need to purchase a 4-inch rain gauge. It's generally about $25 or so. And you can order it from that particular link. And then kind of just fill out the form, submit the application, and then you'll get a response with that. If we go to the map here, let's see here. Go back. So you can see all the Cocoros reports in the country here. So like, for example, in our area, zoom in. So here are the different Cocoros reports in our area. So you can see as of 7 a.m. in this particular location, we had 0.34 inches of rain. Again, they have a rain gauge there. And you can see, like, for example, outside of our area, there are a few more higher amounts, like across parts of the Hudson Valley, almost a half an inch. Let's see, Massachusetts are a couple of higher amounts. So the warm weather season, this is measuring rainfall, and then in the winter, snowfall. So definitely highly recommend you go into this page if you're interested. They are definitely looking for more Coco observers. And with that, that marks the end of our presentation. Definitely feel free to send us an email. There's my email, brian.greenblatt@noaa.gov, and then Jake's email. Our emails are pretty self-explanatory, first name, last name @noaa.gov. If you have any questions, and we'll also open it up to general questions right now. So if you have any questions, feel free to type them in the question box. And as Jake mentioned earlier, he's not able to see this, so maybe we'll alternate answering the questions or something like that. So let's see here. Get rid of that one. All right. You mentioned that macrobursts were greater than 2.5 miles. Is that miles in diameter? Yes. Yeah, that is miles in diameter of the damage path.
And more than likely, the strongest winds from that are going to be propagating with the storm. So if your storm's moving east, your strongest winds are going to be east because it's also including the speed that the storm is moving at.
Let's see here. What is aerial flooding? So aerial flooding, actually, I'll go back to the slide if I can.
It's not the greatest term to describe the flooding.
Yeah, it's actually it's confusing a lot of times with a lot of the alerts we do, and there is warning consolidation. I forgot the exact phrase, but let's see here. Let me go back there. Here we go. Flood. Okay. So you have the flood warning, which may be on like a smaller creek or river or large drainage area. But then an aerial flood warning is when you're basically dealing with more like urban flooding. For example, like ponding of roadways. A lot of times we'll issue a flood advisory. And this is what I meant about a consolidation type of thing. We're trying to consolidate things as an organization. So eventually things may be a little bit more simple. But an aerial flood warning is generally over more of an urbanized area.
Yeah, the official definition, I had to go look it up, from weather.gov is that an aerial flood warning is normally issued for flooding that develops more gradually, usually from prolonged and persistent moderate to heavy rainfall. This results in gradual ponding or buildup of water in low-lying flood-prone areas, as well as small creeks and streams. And the flooding normally occurs more than 6 hours after rainfall begins and may cover a large area. However, even though this type of flooding develops more slowly than flash flooding, it can still be a threat to life and property. So it's kind of like Brian said, it's just a very slow buildup. It's not your flash flood to where you get a ton of rain, 2 inches in an hour, and the water just automatically overruns you. It's more of a couple days long of, quarter inch, half inch every few hours, and it just slowly drains into the rivers, and then the rivers rise, or it drains into other low-lying areas in a more slow pace. Like it said, usually starts 6 hours after a flash flood or after rainfall begins, where flash flooding normally takes, in more extreme cases, it can happen within the hour.
Okay. What ham radio frequencies are used to report weather events? I do not know the answer to that question. Your best bet is to probably email our former warning coordination meteorologist / current acting one. He's now our boss and our meteorologist in charge, David Nicosia, David.Nicosia, Nicosia at NOAA.gov, and he can answer that question. I don't know that question off the top of my head.
Yeah, you'd probably be better, because Dave's a massive amount of emails he gets, just send it to our BGM storm report.
Yeah, maybe we can do that instead.
Because he's doing both jobs of meteorologist in charge and warning coordination meteorologist, so he's inundated with emails a lot, and he gets a ton a day. So if you have anything, that frequency thing, correct me if I'm wrong, Brian, since I've only been here during COVID, but we really don't activate the Skywarn network to like where the ham radio is used too much, because I've only seen a couple times where it's been actually used.
Yeah, this is something that, as you mentioned, with COVID, in the past we would actually have a ham radio operator in the office during a significant severe weather event, but that has not been able to happen during COVID. Yeah, I mean, of course, you have the Skywarn activation that's in our hazardous weather outlook. But in terms of the exact radio frequencies, I'm not quite sure on that. We actually our former ham radio expert retired a couple of years ago, Dave Morford. Some of you may know that name. He was our ham radio expert here, and we don't really have one at the moment aside from Dave. So I'll defer that question to him. Yeah, but I think Jake made a good point. Email bgm.stormreport at noaa.gov, the same email that you would send a storm report to, instead of sending it directly to Dave. It's like Jake said, he's filling 2 jobs at the moment, so he's inundated with emails. Got that one. I'm new to all this. How should I approach my reporting information? You're referring to, like, I'm not quite sure what. Go back to the slide here. This slide works.
Can you read the question again, Brian?
Yeah, I'm new to all this. How should I approach my reporting information? Trying to figure out what well, most of that's.
So kind of just like Brian said, send it to the BGM email. Take hail reports, wind reports, and if you're going to send in wind reports, or you're going to call in wind reports, have an anemometer that actually measures the wind, because a lot of wind gusts are hard to judge if you haven't been in very windy conditions very often. So we'll get a lot of reports of much higher wind than it actually is occurring, just because it's rushing through all the trees, and it seems like that had to have been a 50-mile-an-hour wind, when in all reality it's like 35 miles an hour. So if you're really serious about it, invest in an anemometer, either a weather station at your house, or you can purchase handheld ones from Amazon. But a weather station at your house would be, if you're really into it, would be a good investment. And if you have questions on what kind to get, just again, send us an email to the BGM Storm Report, and we've got plenty of suggestions that we could hand out. From a ton of our meteorologists have their own weather stations, and they can point you in the right direction.
And I got a little clarification here. Should I be careful? So I'm assuming, yeah, the reports only go to us. We don't provide any personal information to anybody out to the public. So if you put your entire address on there, that will not be sent out to the public. We will say in the report, the town name and where you're located, but we're not going to provide any personal information on the actual report that we distribute to the public.
Exactly.
So hopefully that answers your question. Let's see here. I'm traveling outside this bureau's area. Can I also provide severe weather reports at other bureau I'm visiting in? So, okay, so you're outside of our forecast area and you're going to a different National Weather Service forecast area. Yes, you can. You can say you're a trained spotter. Every office has their own procedures. A lot of them have different phone numbers. If you go to that office's website, toward the bottom there should be information on what number to call. And you can say you're a trained spotter, a different part of the country, but you're a trained spotter. So that will, for them, that'll also provide extra confidence about the report. I'm assuming that's what it meant by bureau. I mean, if it's any National Weather Service office, if you're a different part of the world, I'm sure that's a little different.
Yeah, don't go to England and think you're trained in England. That's a whole nother bag of worms.
Oh, okay, a bunch of different new ones here. So hold on, this thing's a little bit glitchy, so give me a second. Do all funnel clouds become tornadoes? No. In fact, many do not. Again, a funnel cloud is the rotating cloud, but that does not reach the ground. A lot of times it'll just dissipate before it ever reaches the ground. Yeah, the short answer is no. What causes a Scud cloud? Get that one. So Jake, feel free to contribute to this as well if you want to. But the Scud cloud, let me actually go back to the Scud cloud example here. Scud cloud. View slideshow. So Scud clouds may be fragments of the severe thunderstorm or fragments of the cloud. Again, it's not rotating. So a lot of times it's a lowering part of the cloud, but it's not necessarily it's not rotating, and that's the main point.
Yeah.
That's I'm trying to think if there's a better way to describe it. Jake, if you can think of a better way.
Yeah, because I've seen it I've seen several before. It's an area of higher relative humidity underneath the thunderstorm, and if you actually see it, you can watch them form, which is pretty cool. And you can see the updraft going up into the storm. You'll see a line, which is pretty much where what we call the lifted condensation level is, to where you lift a parcel of air from the surface, like it's lifting up into the thunderstorm, and as it's lifting, it's cooling. And as soon as it hits a point where that water that's in the air hits that point, it cools into and condenses into a cloud. And you can see it's super cool. It's like this line where it just goes up and then it turns into a cloud. Like Brian said, it doesn't rotate. It's just pretty much an updraft from the ground turning into a cloud in an area that has higher relative humidity compared to the thunderstorm in general. So that's why it's below the base, is just because wherever it's updrafting from, whether there be a pond or a lake in the region that was able to inject some more higher moisture in than the surrounding area, that's where those scud clouds develop at.
Yeah, that was a better way of describing it than I did.
I think they're cool. I love watching them. I sit and I'll stare at them for as long as I can, because there's just the process. It's for us looking at this stuff on models and looking at upper air charts and all that. You actually see the physical manifestation of what you're seeing with all these just lines and numbers. That's the fun part of it.
Okay. Already got that one. For the system, does it have to be both the hail and wind, or can it be either or? So it's either or. In terms of the criteria of severe thunderstorm criteria, it's either or. So you may have very little, if no wind, but if you have quarters falling from the sky, that is severe thunderstorm criteria. And likewise, if you have no hail and you have high wind, as 58-mile-per-hour wind or greater, that is also severe thunderstorm. Okay, got that one. Is there a list of warnings, advisories, statements available that only your office issues? So all the warnings that we issue are nationwide based. So different offices will issue more warnings of a certain type than others, but there's no specific warning that is just for the Binghamton National Weather Service office. There's the same warnings across the board. Now, the caveat is, again, that different types of warnings are used more than others. So, for example, in the winter, this is actually a relatively new warning, a snow squall warning. We do issue quite a few snow squall warnings in our area because we do get quite a few snow squalls compared to other areas of the country. Some offices have like a local policy not to issue special weather statements for certain things, but there's no specific warning or anything like that for particular office. The caveat there too, I just thought of, is that the coastal offices do issue marine warnings. So they issue small craft advisories and gale warnings and things like that. Yep. We are not a coastal office. If we ever become a coastal office, that's a problem. We do have the Finger Lakes, but we don't issue anything for the Finger Lakes. The Buffalo office does issue coastal products for the Great Lakes. So yeah, things like that. The coastal offices do have certain things. There are also offices that have bigger airports than others. So for example, the office that I was an intern at or student volunteer at in college, the New York City office, you have a lot of airports or big airports around New York City. So they have an enhanced aviation program. So they have an extra dedicated aviation forecaster on staff. Things like that. So there's some differences between other offices, but for the most part, it's standardized. Let's see here. Can you include a link for quality anemometer in the emails you'll be sending out? I don't think we can recommend particular products or apps or anything like that, but you can probably just do some sort of a Google search or anything like that. On the Coco website, and there may be some information on there, but unfortunately, I don't think we can provide any recommendations. How do you measure wind shear? That is a very good question. So throughout the country, there are what are called upper air offices that launch weather balloons, and we are not one of them. The Buffalo office does, the New York City office does, the one I was a student volunteer at, but they're spread out throughout the country, and basically that provides measurements, different weather parameters and different layers of the atmosphere. So that is one way to get wind shear measurements. Another way is our radar actually has something called a VAD wind profile product, and that shows the wind direction and speed at different layers. Of course, that's only at the radar site, so it's not necessarily representative of the whole area. There is also there's model sounding, so that we can look at the models and see projected wind shear. And then I know there's some airplanes that do have instruments attached to them that do provide measurements. I don't know if wind shear is one of the things that it can calculate, but I'm pretty sure it can. So planes have instrumentation on them as well. There's many different ways to get observations. And with hurricanes, so I mentioned like weather balloons where you take measurements from the ground up. Well, hurricanes, the hurricane hunters drop what are called drop sons, and basically it's a weather balloon that goes down. So they drop it from the plane, and you're taking measurements from the higher up all the way down to the ground. Somebody said yes, that's what I meant by bureau. Got that one. I just lost it. How do you measure hail and how do you measure rain? So how do you measure hail? You can take a ruler and measure the diameter of the hail. Of course, hail is ice, so it will melt. So if you are measuring it long after it actually fell, it probably shrunk a bit. But yeah, you use a ruler. When you're reporting it to us, you can mention the measurement. You can also have it next to a commonly used object to compare it. And then rain, I mentioned that with the Coco reporting. You can get a rain gauge, a 4-inch rain gauge, and that collects the rain, and you can measure the rainfall there. And then there are some automated stations, weather stations that may, I don't know if it's technically measuring rain, I don't know if it's an estimation or exactly how those work, but that you can get some rainfall amounts on there. Jake, feel free to chime in if you think of something else too.
Yeah, no, those are the main, for hail reporting, the easiest thing to do is, since what we're really, if we have a severe thunderstorm out, or we want to know if a storm is producing a severe thunderstorm, is producing severe hail. If you have a quarter in your pocket and you just stick it next to the hail stone that's fallen that you're looking at, if it's bigger, then you know it's a severe size hail and you can report that it's slightly larger than a quarter, or if it's under that, it's not as big as a quarter. And that helps us understand if the storm is severe, and if we have a warning on it, to continue with that warning and monitor it, or if we don't have a warning on it, to know that we need to look at it closer and think about issuing a warning. Sometimes we get those reports and the storm has already fallen apart and the hail is already fallen out of it, so it's not severe anymore. But it's good to know if that storm did produce something, so we can go back and look at it in archive data and see how we missed it and what we can do to improve in the future.
Who determines when the Weather Service comes out to determine if it was a tornado or straight line winds? That's a very, very good question. So what we do in the aftermath of a storm, of course, we're collecting storm reports and everything like that, but we are communicating with the county emergency manager. So it is the communication between us and the county emergency manager in terms of determining if we're going to go out and survey a storm. We cannot survey every single tree, obviously, and we need to make sure that we're not going out of our way to survey just a few trees down. So certainly we can go that way. But yeah, generally, I mean, unless if we're getting a ton of reports for like one area, sometimes we will reach out to the emergency manager and ask them if they want to survey it, that we may be the first ones to reach out to them. But it's not the public that requests a survey. It's communication through the EM.
Yeah, do not call our office and tell us that we need to go do a survey. It happens several times a year, and we just have to report or point you to the emergency manager of your county and talk to them and go through them, because we cannot initiate a survey, they do. And our emergency managers around here are very good. We have a solid crew of our core partners, and if they understand when a survey is needed and when it's not, and they don't want to waste people's time with doing stuff that's not needed.
One of the things too is a lot of times when you're surveying damage, you're going through roads that are closed because of the damage. So you need we need special access to those roads from the emergency manager. A lot of times we're going on people's property, so we don't want to be trespassing either. So definitely that's why we communicate with the emergency manager. Let's see here, got that one. Okay, the same person who asked about rain and hail, how do you measure snow? That will be talked about in more detail in the winter version of this course, which we teach in the fall. I highly recommend, if you're interested, to take that version. We usually start advertising those in August or September or so, and we start teaching those in October, November, December timeframe. So I definitely recommend you do that. I mean, the short version of the answer is you have the best way to measure snow is you would have a white piece of plywood. It's called a snowboard, and make measurements on that. But you can also use any flat surface if that's not available. But again, I would definitely recommend the winter version of the course to get more information on that. Is there an age limit for being a spotter? Not really. I mean, as long as you're old enough to understand this and also be responsible with this. So yeah, I don't think there's technically an age limit. In fact, one of our former student volunteers here, Dave, our warning coordination meteorologist, former warning coordination meteorologist, knew him when he was a young kid as a spotter. So we, let's see here. Do we need to be retrained to be a spotter? We recommend once every few years or so, every 2-3 years or so, to retake the course, but you don't have to. It doesn't technically expire. It's just more of a refresher. If you're getting a little bit rusty on certain things, we definitely recommend you take it over again. But you don't have to retake it. We don't provide spotter numbers anymore. We used to do that, but we don't anymore. It's just a little bit too difficult to keep track. We do keep track of your location and everything. And this is actually another thing I wanted to bring up. While most of the time, the way trained spotters are utilized are through you contacting us, there will be rare occurrences that if we're looking for damage reports in an area, you may get a call from us looking for, just asking if there was any damage in your area. We're not going to be spam calling everybody, so we're very careful with who we're calling. We need to make sure it matches up on radar. But if we're certain there should be damage somewhere and we're just not getting damage, and we have a trained spotter in that location, we may contact that person. Let's see, so I got that. There's a few comments. I got that one. Are there consumer style weather stations with wind speed and rainfall amount reporting reliable professional weather center? Yeah, again, we unfortunately can't recommend particular brand names.
No, but there are, as long as you don't go super cheap and kind of check the reviews, there's several that are very good. All-in-one stations where it's kind of like one station that has anemometer, temperature gauges, humidity, rain, all that stuff in one package. I've seen those, and then there's others that are more sensors kind of around, but in the same location. When you do set them up, you want to keep them kind of in the open, away from objects, so you can have better rain or better wind measurements and your temperature measurement, if you're curious about it, or if you want it to be accurate, is not influenced by any radiation from a particular source. Myself had one in Houston, and the only place I could put it was on top of a fence. Well, that's awful in the summertime because the sun beats down on it, and the heat and the wood warms up, and so I was getting temperature readings of like 105 degrees when I know it's not 105 degrees, but I just didn't have any options of where to put it. So when it got real hot, it wasn't very useful, but it was good to see when front passages happened and that type of stuff. When that's kind of only reason I really had it, was to see that type of thing, because I thought that was cool. But just pretty much Google search or search on Amazon, and you'll be able to come across several quality things. But just don't. Only thing I recommend is don't go cheap if you want it to last, because it will. They're made with different materials, and you stick them out in the elements, and it might not even last a season if they're made poorly.
Thanks, Jake. I'll answer a few more. Also, feel free if any of you just want to drop off, feel free, because we're getting close to 8:30. But I'll continue answering questions. And before anybody else drops off, thank you all for attending. We definitely appreciate it. This is a great, there's a very large amount of people on this virtual one, the most I've seen. So it's probably why we have so many questions. So thank you all for joining, and hope you all enjoyed it. And definitely stay tuned for the winter version of the course that will be taught in the fall. And then if you're interested, the advanced version, which will be taught on May 11th. So I'll continue answering questions for those who want to stick around. Let's see, who issues the warnings that our cell phones receive when there is severe weather? It is a very loud beep. Does that come from the National Weather? Yeah. So we issue the warnings. So we issue the tornado warnings, severe thunderstorm warnings, flash flood warnings, whatever. In terms of noise on a phone, I mean, some phones are different than others. That's out of our control. But the and of course, when it relays on the TV, as I mentioned earlier, that's out of our control. But we're the ones that actually issue the warning. How it gets to your phone or the TV is not directly from us.
Yeah, for the phones, it runs through, the cell phone company, and then pings off the towers. So if you are in the area of the tower, you will get the alert, but you could possibly not be within the warning area. So if you get an alert, that means there's something in the area. Check a source to see what's happening. So either go to our website on weather.gov/BGM, pull up your local news on TV, or check another source that you trust to see exactly what's going on, to make sure that you are definitely in the warning, because we can't control if we issue a severe thunderstorm warning, say in south central part of Broome County, but you happen to live in an area where a cell phone tower covers that, but you're north of it. We get calls every year, one or two, that want to know why they got a warning on their phone when they weren't in a warning. And it's just the technology. We can't say do GPS locations, because people have to opt into that, and we don't want, it becomes a safety issue if you don't opt in, but you didn't know you had to opt in, and you don't get a warning on your phone, and it ends up costing you or someone you love their lives. That's just not a good option. So the best option is, even if you're inconvenienced by a warning once or twice a year, it's better that you were made aware of something going on in your area than if you were just caught off guard. So that's kind of where the limitations are at with the technology, but it's the best practice that we can do.
And there are newer versions of WIA being rolled out that are a little bit better with location. And certainly we, especially for like snow squall warnings, for example, we're careful with how large we're making the boxes. We don't want to set off everybody's phone. So like snow squall warnings, a lot of times we focus those around interstates, because those are more for driving hazards, not necessarily. I mean, a snow squall doesn't really provide many hazards when you're at home. But yeah, we're definitely aware of certain issues that happen with that, and we try to focus the box on where the hazard is. But yeah, sometimes it's just the nature of the technology.
And if you're getting alerts on your TV that you shouldn't be getting, or you don't think you should be getting, that is on the cable company. It's not on us. It's another thing we get a call with a lot in the summer, is somebody way up in Oneida County will be getting a storm warning for something a couple counties away. And that's how the cable company runs their stuff. And they'll tell you to call us, and then we'll tell you to call them. And we have no control over how the cable company routes those warnings. As long as it gets to the TV, that's what matters, but we can't control if you get a warning over a show that you're trying to watch.
Somebody asked, what is the difference between a microburst and wind shear? So microburst, as I mentioned earlier, is just a fancy term for the downburst. That's the descending air with the thunderstorm causing the wind damage, and that is less than 2.5 miles in diameter. Wind shear is the change in wind direction with height. So the microburst essentially is the damage. The wind shear is just basically it's a measurement of change in wind direction and speed with height. Wind shear is an ingredient for thunderstorms. Microburst is the result of many thunderstorms. That's probably the best way to answer that. I'm a member of the Civil Air Patrol in Oneonta. We had some bad thunderstorms in 2021. One time we had over 1.5 inches of rain per. Yeah, so yeah, I mean, in any given summer, you can have a thunderstorm that goes right over your area and cause some issues. One thing that's interesting with severe weather is it's a lot more localized than snowstorms, for example. So a lot of times you may be severe weather in the area, and you may not get any damage or anything. And if that happens, consider yourself lucky. It's just because you're in a risk for severe weather doesn't mean it's going to happen in your backyard. Is what we like to message. What is the criteria to report rainfall? Yeah, that's a similar question from earlier with the you could use a rain gauge in terms of what if I guess the direction of that question is like what to report to us with rainfall. Certainly if you have high rainfall rates in an hour, I mean that's certainly helpful. So if you have like 1 inch of rain in 1 hour, that's very helpful to report. But when you have with the Coco program, it's anything from 0 to infinity with rain. It's what you report. So there's no criteria of what to report. In terms of what to call into us, it's definitely something of a high rainfall rate or any flooding that's happening. We don't necessarily want to call for, okay, it rained 1/10 of an inch this last hour. But if it rained 2 inches the last hour, that's certainly helpful for us. Is there a list of Skywarn amateur radio repeaters for the region? I haven't heard a net activated in quite some time. I would like to advertise them via AV. Yeah, again, the Skywarn amateur radio thing questions, I would recommend you do email bgm.stormreport@noaa.gov, and then we can pass that along to Dave, and he should be able to answer those questions. I'm not quite the expert on that. I don't want to pretend I am, so.
Yeah, like Brian said, our ham radio person retired, and with COVID and nobody else in the office being qualified, it really hasn't been activated pretty much because of those reasons.
Let's see here. Thank you both. It was great. It says, I see a question. It just simply says water spout. I'm assuming that means what is a water spout? Water spout is basically a tornado that occurs over water. So it's sometimes the way it forms is a little bit different, but in simple terms, it's a tornado over water. So a lot of times, sometimes you can have a water spout make landfall. Let's say you're along the coast and it reaches land, then yes, it would be a tornado or potentially a land spout. There's, again, the way it's formed is a little bit different. Let's see here. Got that one. I think that answers all the questions. Does anybody else have any other questions? Feel free, otherwise we'll start wrapping it up. Somebody said thank you both. This was great, and you're definitely welcome. All right, so Jake and I will stick around for another few minutes or so, probably till like 8:35 or so. And then if there are no other questions, again, have a great evening. Thank you again for joining us this evening. I know it's not ideal to have this in a virtual format. I mean, one of the advantages is we can certainly get a higher attendance, as we saw this evening. But in person, we're looking forward to hopefully doing those sometime soon again. So again, thank you for joining us and have a great evening. Jake, we'll just stick around for another minute or so.
Yeah, until the.
Let me stop recording. How do I stop recording?
Did you see all those?
Here we go. Stop recording.